Hi there, this is part one taping of the Unit 3, not Unit 3, but Unit 4A review that you were given out on Friday. Now remember, students, that it's due on Wednesday, test day. So first thing, if you look at the picture, there are no lines, so we had to eliminate a couple of different ones. So we eliminated secant, tangent, and point of tangency, because secant would be a line that goes through at 2 points. A tangent line would be one that intersects at 1 point, and then the point of tangency would be like point U. Now, in this case, there are several answers for them. I'm just going to give one example of them for each, but the diameter, there's only one possible answer, and that's line segment YS, because it is a chord that goes through the center of the circle. The center of the circle is just point Z. And then there are several chords, but I'm going to pick VW. Okay, and it's a line segment that's endpoints are on the circle. So you have VW, you have VS, you have YS. There are three different ones there. Radius, there are three different ones here. You can choose ZU, pardon me. That's what I'm going to choose. You can also choose YZ, or I could choose ZS. So there are three different ones that you could choose. Major arc. Now a major arc is an arc that is greater than or equal to 180 degrees, and it is indicated by three variables. And the reason that is say I wanted the major arc that goes around this way around the circle and begins at Y and ends at T. Well, if I just put YT, arc YT, that would be a minor arc, not a major arc, because I'd have to go the shortest distance. But if I wanted to go the longest distance, I would need to say, okay, it's an arc. I have Y and T are my beginning and ending points, and it goes through all of these points. Well, I only need one of them to name one of them, and I'm going to name V. But you could have named W, it goes through, X goes through, but I need 3 points. And then semicircle, you can name this by YUS. YUS, or YTS, or YVS, or just the endpoints are Y and S. So moving on along, we have to find the circumference of a circle, and I think for the most part people didn't struggle with 11 and 12. You're just plugging it into the formula, and the formula here is circumference is equal to 2 pi r, or the circumference is equal to pi times d. Okay, so in this case I'm given radius, so I'm going to use the 2 pi r, and I'm just going to plug it in. 2 times pi times the radius of 6.9. Now I'm going to it says to use my calculator's value of pi. So in my calculator, I'm going to say 2 times pi times 6.9, and my answer is 43.3. And I'm rounding to the nearest tenth. The circumference is equal to 43.3 inches. 43.3 inches. The next one, I'm given diameter, so I'm using the formula C is equal to pi times D. So C is equal to pi times 24, and I plug it into my calculator, 24 pi, and that is equal to 75.4 centimeters, because it's rounded to the nearest tenth. Now, number 13 is a little trickier because it gives me the area, but I want to know the circumference. So if you look at your formula sheet, you know that the area of a circle is pi r squared. And so I'm just going to plug in 201.1 for area is equal to pi r squared. So then I have to use my mad algebra skills and solve for r. So I divide by pi, both sides. And so I have 201.1 divided by pi. And I can see that 64.0 is equal to r squared. And then I take the square root of both sides. So 8 is equal to r. And then I plug that into the formula for circumference, and it's 2 pi times 8. So then I plug it into my calculator, and my answer is 50.3 meters. Now notice it's always just units because it's measurement. You're measuring a distance, so it's just units. Now when I get down here to area, it will be in square units because it's pi r squared, and I'm squaring that radius. So first thing I need to do here, it gives me diameter, so I need to change it to radius. And then I plug it into my formula, and then I plug it into my calculator, and my answer should be 153.9 miles squared. Radius I'm given as 9, so again I just plug it into my formula, 9 squared, and so it is 254.5 yards squared. Now, number 16 gave people some trouble today, and once we go over it, I think that you will be surprised. So this is my standard equation of a circle, and this is on your formula sheet, so you need to be familiar with where it is because you will get a formula sheet for the test in the EOC. So it asks you to find the exact area. Now, exact means in terms of pi, not rounded, okay? So I'm going to just say pi will be an answer. So I can see from the formula that r squared is equal to 55. And I want to find the area of the circle, and it's pi r squared. So I don't need to find r. I want r squared. So I'm going to plug in 55 for r squared. So pi times 55. So the area is going to be equal to 55 pi. And that would be, I don't know the inches, I don't know the units, so that would be the area square units, whatever units it may be. So it's really important that you be able to interpret the formulas and use them and be able to use one to plug into another. Okay, flip the page. We'll do the front and back on one video. So use the information provided to write the equation of each circle. So the first thing I need to do, the highest high, the lowest low, left is left, the right is right. And so it's -4, -3 is my center, and then 1, 2, 3, r radius is equal to 3. So writing my formula, or the formula of my circle, you should have this at the top of your page. Y minus k squared is equal to r squared, and hk is my center. So when I put this into the formula, it goes x minus -4, so it becomes +4 squared, plus y minus -3, so y plus 3 squared. And then r squared in this case is 9. Next one, moving on along. Oop, did I do that? I think I did that right. Highest high, lowest low, left is left, right is right. So my center is 1, 1, and then my radius is 1, 2, 3, 4, 5, 6. Okay, so I have x minus 1 squared plus y minus 1 squared is equal to 36. Now they get a little bit more complicated. Well, number 19 isn't. I'm given h and k, and I'm given my radius, so I just plug it into my formula. X minus 4 squared plus y minus 2 squared is equal to 64. Now, this one's a little bit different because you have to, number one, you have to find the center, which is the midpoint between these two. So the midpoint formula is x1 plus x2, and we can use the formula. We didn't talk a lot about it, but I know you've used it in the past. And then the y value will be y1 plus y2 divided by 2. So in this case, it's -7 plus -1 divided by 2, and 6 plus -10 divided by 2. So this would be -4, and that would be -2. That's my center. Now the next step, you do have the formula of the distance formula on your formula sheet. And you can either use the distance formula or you can use the Pythagorean theorem. And so in this case, I knew if I would have used a grid, and just for time's sake, I'm not going to do that, I can use the Pythagorean theorem. And I know that this distance between -7 and -1 is 6, and the distance between 6 and -10 is 16. So I just do a squared plus b squared is equal to c squared, which is going to be your diameter squared. So 16 squared plus 6 squared is equal to c squared. I use my calculator, plus 6 squared, and then take the square root to solve for c, and that's 17.1. So c is equal to 17.1, and that's the diameter. But I need the radius, so I divide it by 2. And so radius is equal to 8.5. And then from this point, I have all my information, and I can write my equation of a circle, and it looks like I might be losing some room, so I'm going to write the equation of the circle up here. x plus 4, because my center is at -4, squared plus y plus 2 squared is equal to 8.5 squared, which is 72.25. And that's your equation of a circle. Now there's a lot of steps to that one. Center here in diameter, I just changed the diameter to radius. So I have x squared, because it's just at 0, plus y plus 1 squared is equal to 4, radius squared. This one, I know that you'll probably see one like this on the test too. You have the center, so x minus 4 squared plus y minus 1 squared, but I don't know what radius squared is. So at this point, I use these points as x and y, and I just plug them straight into the equation. And so I have -8 minus 4 squared plus 6 minus 1 squared, and we can do this, so it would be -12 squared plus 5 squared, and so that's 169. And that is what your r squared is equal to. So if I asked you this type of question on the test, and I asked you what the center was, you have the center, and if I asked you for the radius, it's just 13. Number 23, the first step that I need to do to determine if these are in, on, or outside the circle is I need to write the equation of the circle. So I have x plus 6 squared plus y minus 4 squared is equal to 16 from the information I'm given. Now, I use each of these points as x and y. If the answer is equal to r squared, it's on, less than r squared, it's inside, and greater than r squared is outside. So that's kind of like your cheater notes there. So I just start plugging them in. And when you start plugging them in, I'm not going to do that for you. You can do that on your own. I find out that when I plug it in, it's 5, and 5 is less than 16, so it's inside. When I plug -4 and 4 in, the answer is 4. Then it's less than 16, so it's inside. And the same goes for -7 and 3. The answer is 2, and it is less than 16, so it is inside again. The next one, 24, has to do with completing the square. So I have x squared minus 8x, so I group my x's and my y's first. Y squared minus 6y plus some number is equal to -21. And I get -21 because I subtract 21 from both sides. And then I'm going to have to add whatever I add to the left side to the right side. And I do it this way. At the same time, I go ahead and write my standard equation so I can put in my values that I have. So the first step I do is I take b divided by 2. So -8 divided by 2 is -4. And then I square it. That's what goes in there. I take b divided by 2, it's -3, and then I square it, it's 19. And then I take 16 and 9, add them together and subtract 21, and it's equal to 4. So that is your equation of the circle in standard form. 25, 26, and 27 are very similar. First thing I know is I want to find the measure, so I wanted degrees. That means I want it in degrees. I'm given that TU is 49, and I want to find WSU. So I want to find this whole degree here. Well, I know this is a semicircle, and that's 180 degrees. So I take 180 and I add 49, it's 229 degrees. Number 26, I kind of do the same way, KHJ. And so that's all the way around here. So I know that this part right here is 180, and then I know that 75 and 43. So I need to turn on my brightness a little bit. My lights just went off. Okay, and so now my lights just come back on. I can just add up 180 plus 75 plus 43, and that's 298. Next one, BCD. So I want BCD. Well, I know that this is 90 degrees because of the right angle. And I know that what's left of the semicircle is 90, so I divide that by 2, and it's 45 each. So then 90 plus 45 is equal to 135. So that's part 1 of